Hello, everybody. My name is Roger Esson. I am the head of industry and partner network at OGTC. I'm going to give you a little bit of an overview about OGTC and the work that we do from Aberdeen in the northeast of Scotland. But hopefully what you'll see today is that what we do and what we are doing going forward linked to the journey towards net zero that most countries in the world are now on, and great to see that the Biden administration is moving forward in the same direction as we have been in the UK. It'll hopefully give you a feel for the opportunity that comes with the energy transition, and this is not hastening the demise of oil and gas. It is very much seeing oil and gas as part of the transition journey. So lots of opportunity to go with it. Just a little bit about me before we start. I am a chartered surveyor and a member of the Royal Institution of Chartered Surveyors here in the UK, and I've been in the oil and gas industry for most of my work in life now. The biggest part of my recent past has been in the world of decommissioning of oil and gas infrastructure, and I led the trade association Decom North Sea for 2 years before I came to OGTC. And I guess my connections with CII, we've been in discussions with Stephen Mulva now for probably a couple of years, since he first presented on OS2. And when he did that presentation on OS2, it very much resonated with me. And we've been trying to see if there are any industry and academic projects that we could get up and running, because the similarities with what you're doing in the States and what we're doing in the UK, it's the same types of infrastructure, it's the same challenges. And interestingly, just as you're talking about lessons learned there, when I was at Decom North Sea, we kicked off a database called L2P2, the Late Life Planning Portal, and I've very much recognised some of the challenges you've got there. But also the OGA, the Oil and Gas Authority in the UK, did a report a little over 20 months ago now, which looked at 30 projects in the North Sea and showed that they typically had a 10-month delay and 35% growth in the cost of projects. And hey, here we are about to go into what could conceivably be one of the largest construction projects in a generation. So hopefully we'll have some questions towards the end of this, and I think it's like most of the webinars we're on these days. If you put them into the chat, we can pick them up. But in terms of OGTC, we came into existence in 2007, funded partly by both the Scottish and the UK governments, and we had funding for a period of 10 years. And what we've done as an organisation is we work with partner organisations. So we have 63 partner companies at the moment, and those partner companies come from oil and gas operators, supply chain, the tier 1 engineering type contractors, small, medium-sized businesses, all the way down to individual technology developers themselves. And what we do is we co-invest in the development and subsequent deployment of new technology. So effectively, we help to de-risk the development of new technology, primarily focused on activity in the North Sea. And to date, we've co-invested with industry over £176 million. We've screened over 1,300 technologies, and we have either 280 projects that are either in flight or have been completed. But one of the important things for us is the access to facilities for field trials. And we've either carried out or have planned 115 field trials to date. And that's everything from some of the things you see on the screen here, the OPT platform PowerBoy, which is a wave energy device that was deployed in the central North Sea, providing power to a subsea template, all the way through to drone and robotic technologies, and into digital technologies as well. But where are we at the moment? Well, I think we've all realised that even since the OGTC was formed, and our objective at the time was to develop new technology and maximise economic recovery for oil and gas in on the UKCS, the world has changed, and you'll recognise 4 of the big oil and gas operators who have all come out now publicly and stated their intentions in changing their businesses. And of course, Total, the name change has actually been implemented since this slide was pulled together. But very, very much the large historical oil and gas companies on a journey towards becoming international energy companies. And what that's meant is that we've had to look at OGTC as an organisation and what the part is that we're going to play as we go towards the net zero targets of 2045 as set by the Scottish Government and 2050 by the UK Government. Of course, within this, we've also got the industry's own targets, which our trade association OGUK has set, and that's on a 50% reduction in emissions by 2035. So the industry itself in the UK has committed to some significant emission reduction targets itself. So although the focus of our organisation has changed and we are now much more focused on net zero and net zero technologies, the purpose of the organisation is still exactly the same as it was. And that purpose for us is threefold. It's to enable the oil and gas industry to diversify and to maximise the opportunities in the transition to a net zero future. We're still here to invest in and to help technology developers to develop technology and, importantly, to deploy it and go for full adoption of those technologies. But we also have an element that we do, which is in inspiring people, and that has a number of different elements to it. Number one is the STEM activity that we do with the schools and the colleges locally. Our chief executive, Colette Cohen, is very involved with the Powerful Women group. So actually, how do we encourage women into senior positions in the energy sector and increase the diversity of our workforces? But we also have a technology accelerator, which I can talk about a little bit later on, called TechX, which is a 16-week accelerator program that gives 10 companies per year access to resources, people, and companies that would typically take them anything between 2 and 2.5 years to achieve, if they were even able to open some of the doors that we're able to open as part of the program. But what I'm going to quickly do now, and Pippa, jump in and tell me if you can't hear the audio when I run this video, but it's just a short video that explains our technology roadmap. So what we've done is we've worked with our industry partners to come up with the key focus areas, and the 3 focus areas in particular, all related to net zero, and identifying where the gaps are that we should be focusing technology developers and academia going forward.
The world around us is changing at an incredible pace. We must adapt and innovate to deliver a sustainable future. You have an important role to play. Work with us to create the technologies for a net zero North Sea. We're investing in partnership with industry, government and academia to develop and deploy affordable technologies that reduce emissions offshore, create an integrated energy system, and harness the full potential of digital. This is our roadmap. Join us on the journey to close the gap on exciting new technologies. Our first program is emissions reduction. We're developing affordable solutions to help reduce operational emissions to net zero while maximizing the full potential of the North Sea. We're focused on field development, minimizing environmental impact and cost across the life cycle. Production, operations and logistics, delivering alternative power and eliminating emissions offshore. And late life and decommissioning, creating a circular economy where infrastructure is reused. Our second program is energy system integration, investing in technologies to support the growth of offshore renewables in partnership with oil and gas, including new storage solutions and clean energy hubs, investing in innovation to deliver affordable green and blue hydrogen and other clean fuels, driving down costs to accelerate production at scale, and investing in carbon capture, utilization and storage, enabling industrial decarbonisation and affordable next-generation energy. Our third programme is Offshore Energy 4.0, accelerating solutions for remotely controlled operations, empowered by data, automation and robotics. Our goal is to create a smart net zero North Sea, lowering costs and emissions while increasing efficiency, automating the offshore energy system, securely unlocking the power of data, embracing new materials, and extending the use of robotics and autonomous systems, reducing the need for people to work in hazardous environments. This is our technology roadmap for a net zero North Sea, but we can't do it alone. We need your challenges, ideas and solutions, your support, commitment and investment to make it happen. We're OGTC, Technology Driving Transition. Work with us to reimagine the North Sea, enable our supply chain to diversify, extend the life of assets, drive affordable green growth, and make net zero a reality. Hello, future.
So hopefully you saw and heard that okay down the line. In terms of technology, we've got a great track record now of the technology that we've delivered across all of the existing or the current programs, and that's in everything from alternative power, non-intrusive inspection technology. Drone technology in the early days was a fairly significant part. The facility of the future and tieback of the future, all of which are applicable in CCUS as they are in the production of oil and gas. Robotics, digital, and that funny-looking device at the left-hand side there is a buoyancy device that we've demonstrated now can lift almost 200 tons from the seabed without the requirement for a crane or a heavy lift vessel, just by using what is basically modified plastic pipe. But we've demonstrated that can lift from the seabed. Did I hear someone there? No, I'll carry on. But as we move forward, the transition itself, and this is where some of the discussions with Stephen have been quite interesting, that we've got so many partners and stakeholders involved in the transition, and that's everything in the UK, from the existing oil and gas owners, the owners of the infrastructure, the pipelines, the reservoirs that we may use for CCUS, and then when you start talking about coming inshore, we deal with the Crown Estate. There's the Oil and Gas Authority, the Department for Business, Energy and Industrial Strategy, but also working with various other industry bodies. So as part of the energy transition, what we're doing is all about how we collaborate, how we work together, and how we can accelerate the development and deployment of those technologies. And through this presentation, you'll see us talking a lot about the North Sea, but actually the technology that we deploy in the North Sea, or we trial and deploy in the North Sea, is pretty much applicable to all of the energy producing basins on a global basis. So last year we did two fairly significant reports. Both of these documents I'll talk about are available on our website and are free to download as a PDF. But the Closing the Gap report was the first one we did, which was looking at the technology requirements for a net zero North Sea through to 2050. And what that report highlighted was that there was a significant investment required in emissions reduction technology. And that's everything from how we decarbonise offshore power. So can we switch off gas turbines and diesel generators and run on an alternative? How do we really develop blue hydrogen at scale? And that means we actually have to capture the CO2 and capture the CO2 in a cost-effective way. And the significant opportunity that there is in scaling up offshore wind. So offshore wind is definitely something that will have a massive impact in the North Sea and the power requirements of the United Kingdom. But is there a way of even powering platforms from renewables offshore? Then you move on to the longer term challenges, and this is where perhaps there's more requirement of input from academia on how we get to green hydrogen at scale. The whole digitalization, automation, use of AI that we've just been talking about, and how we learn from the projects of the past. And then we get into the energy storage and the transportation side. But CCUS, significant opportunity, and it's also an opportunity for jobs in net zero. So this is the continuation of the great work and the technological advances that we've made in oil and gas, and how that can move into the net zero future. So that then led into the follow-up report that we did, which was the Integrated Energy Vision, again available on our website. And to give you an order of magnitude to this, we currently estimate that the UK is going to need, by 2050, 60 gigawatts of offshore wind to provide 85% of the UK's power from renewables. And that's a requirement of building somewhere in the region of 4,000 offshore wind turbines. And there's a lot of activity at the moment on moving from monopile wind turbines that you can see in the image in the center of the screen there to marine-based technology, and the technology that in oil and gas we will recognize with floating structures. And we've even got a project at the moment that's a tension leg project that's based around the same technology as has been used for many years on mid-water arches. So it's how do we take that knowledge and experience from oil and gas and apply that to the new world. And at its highest level, the estimate of the investment required to facilitate this transition is in the order of £202 billion. Think about that number. In the UK alone, over £200 billion required. And this is technology that can be used globally. But to give you a little bit of a feel for where we are, this was taken about an hour and a half ago from a site called iamkate.com, and it's a view of what's happening in the national grid, the electricity network here in the UK. And it's interesting to note that despite all our current efforts, only 28% of our electricity tonight was coming from renewables, and 5.5 gigawatts of that is coming from wind. From our perspective in oil and gas, the very interesting part is that 31% of our electricity requirements in the UK is coming from gas. And that is not something that's going to be replaced quickly. The good news story is that we're down at 0.7% for coal, but there is still a requirement for fossil fuels to produce electricity today in the United Kingdom. And that's the real scale of the challenge if we're going to move on the deployment of renewables. So the roadmap. I'm not going to go through this in detail because, again, it's on our website, and in a few weeks' time, we're going to be launching the next levels down on the technology roadmap. But it covers everything from field development, which people are still surprised about, but that technology development work we did for Facility of the Future is directly transferable into what we're going to do in CCUS, and perhaps for the geological storage of hydrogen in future as well. Production, operations and logistics, that's about decarbonising what we do every day. And then decommissioning is an opportunity for us to look at how we attack that significant challenge, which there will be with renewables at some point in the future as well. but how do we do that in an entirely different way? ESI, very much that hydrogen story, alternative fuels, ammonia is starting to come into that discussion now as well for marine transport, and could we even power platforms with that? And then everything digital that's covered under the Offshore Energy 4.0 program. So that's the work of what we call our solution center, and that's where we work with tech developers, we work with academia, we work with anybody who comes in with an idea that we can garner industry support to take forward. But what we also have is our technology accelerator, and this is the program TechX, where we work with pre-revenue companies who come to us with a spark of a good idea, and we help them to develop and to grow their businesses. So we now have an ecosystem of around 30 companies that have gone through the program, and this year's program, I should say, which will go live in Q4, will be open to companies globally. We've had companies from Canada, from the US, and Europe, across Europe, in the previous cohorts. So we'll be coming out, and this is an open program that anybody can apply for. And we'll be able to share the details of this through Pipper so that you are aware of it. And if there are any organizations that you're aware of or small companies that you think would fit with the program, be very welcome to have a discussion with you on how we support those. But when we look at academia, we have two academic institutes in the northeast of Scotland, the University of Aberdeen and the Robert Gordon University. And what we have with them are what we've called our two national centres. So our National Subsea Centre does exactly what it says on the tin. This is focused on all things blue economy, not just oil and gas, but it's focused on the expertise that we have in subsea here in the UK. And much related to the discussion before mine tonight, the applicability of AI and data science. And there's a project up and running at the moment called SciBOC, and that's really taking data from ROV surveys and actually teaching the machine, using machine learning, to identify anomalies. And the overall aim here is, could we actually have autonomous underwater vehicles just acquiring subsea data and then machine learning and looking at the data and telling us where the anomalies are without any human intervention. So we're currently working to train the machine to identify anomalies. And the National Subsea Centre has got three research themes of subsea engineering, AI and data science, and integrated energy, looking at everything from circular economy through to intelligent operations and what we've called the smart basin. So if we looked at the North Sea in the same way you would a smart city, would we unlock doing things differently? And everything through to zero emissions power for offshore. Our National Decommissioning Centre is the partnership with the University of Aberdeen, and one of the things we've invested in heavily. And just before I finish up, which is only a couple of slides from now, I've got a short video of what we are working on with our marine simulator. So we have a 300-degree immersive environment that we have built in partnership with our colleagues at the Offshore Simulation Centre in Norway. And in the simulator, we can run everything from smart city scenarios through to individual scopes of work on a platform, virtual prototyping of tools, all the way through to planning an entire decommissioning job. And that's all backed by a physics-based engine to which we also have access to a reduced basis finite element analysis module 2. So we can export the data, run the analysis, and then port it back in to be able to visualize it. And the NDC's program is very much focused around how we do things smarter, how we do things safer, how we decarbonize and do it cleaner, and how we reduce the cost, because in the UK government is on the hook for 50% of the cost of decommissioning, which is effectively a refund on overpaid tax, but it's money that isn't actually sitting in a bank account anywhere waiting to be spent. So I'm just going to move on and run the video, and then I'll wrap up at that point. But this is just a very short video of the simulator at the National Decommissioning Centre. And this is not our dome. This is the one in Norway that ours is based on, with 4 control chairs in it that you can run ROVs and marine operations from. But what we've done in the simulator already, and it'll pause here to show the model of the city of Aberdeen that we've done, and anybody who's been in Aberdeen before will recognise the harbour and the centre of the town. And what we're going to do here is overlay city transportation data so we can start to visualise it. This is the new harbour, the South Harbour, that's currently under construction, modelled differently. These are hard surfaces. Those vessels will get damaged if they collide with the harbour walls. This is a very quick run through that we did with a contractor and a buoyancy device for the removal of steel pile jackets, when we were able to demonstrate that the system could work in the simulator. And it was very calm conditions in the North Sea that we're showing here, which isn't normal. But we started to then look, well, how would we take a jacket into Aberdeen Harbour and get it off a barge and onto the quayside? And you wouldn't do it on the breakwater side, but it just shows what you can do in the simulator when you're running scenarios. But we'd need to build a crane. So let's just build a crane on the quayside. And this is a 5,000 ton offshore crane, typical on a semi-submersible crane vessel. And what you see here, when the jacket is picked up and the crane moves, when it stops, and this is speeded up, you'll see the movement that you would get in real life on the simulator. And of course, we can play around with the weather conditions, the tides, and so on in the simulator. You can also visualize what's on the seabed. So that's a 972 ton manifold up at the top left. And this is a virtual trial of a buoyancy device attached to an ROV, lifting 200 times its own weight. Then in the new world, in renewables, you can start to you can visualize and scenario plans, or how would this connect to an offshore power grid. Those lollipops that you see there are just a way of visualizing data, the same as you would with a smart city, and the technology here is the same that is used by the UN Smart Cities program. So that's a glimpse into what we're doing with the simulator and how we're working with industry and academia. And that's it. That is my very, very fast run through of what we're up to at OGTC. Hopefully that will have sparked some interest, and when I stop sharing my screen in a second, we'll see, or I'll see if there are any questions. But certainly happy to follow up with any opportunities to work together. We've got access to various funding routes here in the UK. And as I say, I've been talking to Stephen on and off for some time now, and I'd be really delighted to get some academic activity linked up between the universities here in Scotland and in Texas. So thanks very much for listening, and hope we've got some questions.
We do have a couple of questions for you. For your tech accelerator, how do you manage the intellectual property issue between your stakeholders? And similar to that, can you expand on how a partnership provides to owner companies?
So good couple of questions. From an IP point of view, the way we manage that, the directed project agreements that we have, we are very clear that we are only here to help to progress the technology. We don't have any share in the technology. So all of that IP will stay with the tech developer. Now, there is a caveat or two to that, because depending on who's been involved with the project, the operator or the other companies involved may take a stake in that to move it forward. But by and large, the IP that the developers come with stay with the developers, and we are measured by the government purely on the gross value add that we bring, and how we can we demonstrate that in supporting the development of that technology, we've created more jobs, more tax revenue, and other things like that. So we're less worried about the IP part of it, but all managed through the legal process. What was the second part there, Pippa, on the owners?
Can you expand on how a partnership provides to owner companies?
So the partnership, if it's the model that you're thinking about here, the model of partnership with OGTC is very much based on we have a partnership fee. And I usually do the fee in inverted commas, and I'll explain why. Because it's never our intention to invoice the partner for their participation in OGTC. It's always based on the premise that if you're inside the camp working with OGTC, it's because we're jointly working on projects together. And the contribution to that project, yes, we would like cash to put into projects, partly because it helps our money to go a little bit further. But what we really want from particularly the owners and the people who have got locations where we can trial equipment is access to the facility for the field trials, access to data. We can value data that you provide to us as in-kind contribution. And what we also have is we have a number of companies who second people in from their businesses as well. So for the owner-operator companies, if you provide engineering resource into us, we'll recognise that as in-kind contribution. And actually, for the individual, there's a learning experience that comes with it. And while you're inside working with OGTC, we just look at you as one of our own employees. You get access to everything that we do and everything that we see, and get a laptop from us as well. So you very much just become part of the OGTC team. But for us, that's what the partnership's all about. We've moved from calling everybody members, because that just suggested that we would be, you pay a fee, you get a magazine, you get a few things from it. That's not what we're about. It's all about the partnership. It's all about the joint industry working that we can do, and doing it at pace.
Great. We have one more question. Are there some AR, VR, MR projects that you are excited about?
You better believe it. So I was delighted. We're working with a company called Visor. Visor are a small technology company from Hull in the north of England. And Visor have a platform that's using Microsoft's HoloLens technology. We currently, right now, we have a trial ongoing on a platform in the North Sea using augmented reality to replace paper-based systems. So this is a big step from a tablet-based system where you're carrying something around. This is bringing the work instruction to the operator in the field. And one of the things, the reason we're doing it offshore is, number one, you remove that excuse of, oh, it's never been used offshore, therefore we can't deploy it. But it's also, as much as anything, to test the connectivity issues that we know that there will be on various installations. And although there is a rudimentary 4G network around the North Sea, connectivity can be a little bit problematic. From a virtual reality point of view, yes, we've got there are some exciting, I guess probably call them Oculus-based VR technologies out there, and having multiple people on a project and on a site from remote locations. The HoloLens one does that to a certain extent as well, with a remote access to a specialist. But a lot of the work that we've been doing in acquiring data through the use of drone technology, all the way through to one of the projects which I didn't really go into detail on at the National Decommissioning Centre is the Smart Basin project. So what we're trying to do there is to build a digital copy of the North Sea and the infrastructure within it, so that we can start to look at the basin and make basin-wide decisions. So it's a complex setup in the UK where we have something like 63 operators in the North Sea, and trying to get those operators to act as one is nigh on impossible. But what we can do with the simulator is, if we have scenarios that we can run in there, we can point out where the areas of opportunity and where it is just blindingly obvious when you take a step back, that if you joined things up, we would be able to do things in a different way. And that's where I think the link with Stephen and OS2 and Prairie Dog starts to come in, and how could we deploy that methodology and that technology to what we're going into now, which from a renewables point of view is a fairly major capital investment project. And as I said at the start, in oil and gas, we're not particularly good at running projects to time or on budget. So how great would it be if we could simulate much of that interaction in a system now? That's the one that gets me properly excited.
Do we have any other questions? All right. Well, thank you